here. All right, we're on 4.5. We're going to go backwards now. Where this is find the equation we've been graphing so far. And so now the question is, what is this going to look like as an equation if I give you guys a graph? Easy one. Let's start off with the easy one here. It's just going to go this way. That's all the information you get. I guess one quick note is because phase shift takes a little bit of effort. If you look at a graph, remember just by doing a phase shift, you can change it into sine and cosine. So what you want to do really is to say, and this the rule of thumb is if it starts on an extrema, which means a minimum or a maximum, we're going to use cosine for the most part, right? If it starts in the 0, 0 position or the middle position, we use sine as the model for it. A lot easier to do so that you don't have to do the phase shift. All right, and anybody done yet? Let's see, that looks like a sine or cosine. What do you guys say? Cosine. Cosine. So first thing is, second thing is flipped or not flipped? Yeah, it's not flipped. No, this is a nice little cosine curve. Boom, boom, boom. The only thing I see is a vertical stretch or amplitude change. Is that right? So at this point, let's go with it here. How about, you could put y equals, I guess maybe y equals would be best. Cosine curve is generally starting at 1 and goes like this, right? Down to -1. So the only thing we have different is just amplitude change. That's it. So how about 2? Oh. Cosine of x. Are we good there? Of course, have to start off simple. Okay. 3 people still finishing up writing it. Any other housekeeping stuff you need to be mindful of? Let's see. No, just the schedule. I need to send you guys a link to the schedule as well, right? Just so you guys. Weebly site. So you need another one or no? Are you guys okay? You guys can find if need be. Okay. All right. Exercise 2, all yours. Try this yourself. Actually, no, let's try this one together. Let's use the same one here. This is going to be pi. So, of course, as things get more complicated, of course, we're going to start using equations here. So here's the equation. Because number 1 was the easy one. You can kind of guess and put it together here. Here's the wonderful, massive equation. Cosine. Even maybe it'll make it like this. Boom. So do you guys remember in algebra 2 where we did that with transformations, right? The h and the k move the function a certain way, right? The number front. Okay. Oh, you know what? Also, it took me only half a year of school to figure out, I could just change this desk around so my knees are not hitting the front of the. Okay. All right, so what we normally do in this case, we start solving for things. Then the 2 things that we usually solve for the most is this one here. A is for amplitude, right? And that's pretty easy. We can sort of set that up. And we look at the graph. We notice that expansion of 3, right? 3 to the -3, that's an easy at 3. For this one, for the period now, so A is taken care of. B is taken care of by this little property. And I guess we should mention, let's back up just a little bit here. We have 2 sort of different formulas functioning at the same time. We should kind of mention this. It's bx plus c plus d or minus d. You guys remember that little formula that we used? That was, so yeah, it was, we used it a couple of times on the difficult ones here. We usually do this one in order to graph. Now, whenever we factor out that b and make it x minus h, we usually use that one in order to gain the equation. Do you guys remember in algebra, if we kind of did the same thing in algebra, we had two different formulas, one for graphing easily, and all of a sudden we changed the one to getting the equation of a graph. No ringing of bells? I think very vaguely.
Definitely we're taught it.
We remember that we did it.
There's no way to tell.
I almost said learn.
Good choice of words there, Greg. Okay, to graph something is lines, we use this little formula. Do you guys remember that one? Y is equal to x plus b. That formula is used. It was great because you figure out what the b is, you move it with the m, and you're done.
Or
Now-
is that x like x minus something and times x minus something?
There you go here. To get the equation of a graph, what we did is,
Oh, is it like the point?
you guys fill in y minus y1 is equal to, m and x minus x1. You guys remember that
Yeah.
formula from a long time
Yeah,
ago?
we do.
All right, so that was the distinction between the two. One was the easy graph one was to get the equation. We kind of do the same thing in trig as well here. So this is to graph mostly. Are they interchanged sometimes? Yeah, you can, but for the most part. And this is to get the equation. EQUATION, equation.
And is it bx plus c or minus c?
Minus c, always minus c, remember, because it's,
Opposite.
goes opposite direction. Okay. Okay, so how do we do this? What do we do with b? We go like this. We go with the period that we know. Period is equal to 2 pi over b. And so in this case, perfect. The period that we have here is pi. This is 2 pi over b. So we just solve for b. All right, good there. I think we have to do is multiply both sides by b, because these b's will cancel. Left with b pi is equal to 2 pi. So a little bit of some algebra work here. B is equal to 2. Got that one solved. Then at that point, then you're looking for a h value. If you see it, it's changed up a little bit here, and that's easy to plug in because wherever you start, you're just going to plug in that h value. And if you think there's a vertical shift, you just use that and you're done. So really easy formula to put together, but I think we've got our stuff done. No vertical shift, no phase shift. Looks just like cosine, and we're done. And of course, there's a fun little mistake here, but I'm waiting for you guys to say it.
Well, it's a reflection.
Hey, it's reflected about the x-axis, so let's put a little minus there, and done. Okay. Think you guys can handle some tough ones now. Three. Let's see. Still stay on cosine? Yeah, let's still stay on cosine. No, we'll go like this. We'll go pi over here. And we'll start off at -2, -3. Okay. I think that's what I want. All right, and then the instructions is give a y is equal to sine and y is equal to cosine function. So I would like both. So they're going to give me the cosine function and the sine function. All right, so first things first, probably should fill in this whole piece right here, the x-intercepts.
So
That'd be
for
kinda useful.
cosine is for sine, is the equation the same, like the y equals a sine and then b times x minus h? Is that the same as cosine?
So let's see, the A is gonna be the same, B is gonna be the same. The K will be the same at the end. The H has to be different because sine and cosine are tweaked off of each other by pi over something, whatever it is.
Okay.
All right, so let's start here. So first things first, my little formula, A cosine B x minus H plus K. Bam. Talk to me. A is equal to 3. Are we all agreed there? Anybody finished it up already? Okay. And then we have this. This is fun. Let's see. I'm going this way. So if I fill in the pi over 2, that gets me 1. Is that right? That gets me 1 full cycle here. So I got this guy to deal with here. Pi over 2 is equal to 2 pi divided by b. And you guys get to solve for b. Let's see. I'm thinking since this is a 2 fractions equal to each other, crisscross if you like, or multiply by 2b on both sides. I'm left with b pi is equal to 4 pi, and voila. Everybody okay with b is equal to 4? Boom, 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 got that. And thinking I'm good. I'm gonna go with -3 cosine of 4x this time. The h is 0, right? Because we haven't moved cosine and we have not moved up and down. All right. So now the sine curve. Period's still the same, is that correct? Period has not changed. The amplitude has not changed. Meaning how long it takes sine to start and then eventually stop.
No, it should be the same.
Still the same, right? So the only thing that we kind of think about is if this was a sine curve, it would have started right here, right? A regular sine curve. And then it would have went up, it would have went down, and then would have stopped right here for that cycle. We're good? So really, we're just off a little bit here. So now the question is how much? I need to know what that guy is. What is that guy? Pi over 8? I think so. Let's see. If I go half of pi over 2, this would be pi over 4 is right here. Everybody good there? And then if I go half of that, this would be pi over 8. You guys talk to me. Does that make sense? So really what we have is we have a cosine curve that's shifted over to the right, pi over 8. I think we're good. So the only change here is that this guy is going to become pi over 8. That's why we like this whole, that b value being a multiplier out, because it isolates the phase shift. So how about this? Y is equal to, oh, hold on. And then the question is, you know, when it hits right here, that's not a reflection anymore, right? That's just a regular 3. So 3 sine.
Wait, so the phase shift is pi over 8.
Pi over 8. So in this case, what we do is we set up the b value exactly how it is. It's 4 parentheses x minus pi over 8 plus k, which is technically 0. Okay, we're good there. By having a b being a multiplier to the x and the h, it allows us just to isolate that h to be the movement from away from 0. That's h right there.
Do we have to add the plus now?
No, I just kind of do it this way. So you guys will see it in the back of your books. You guys will see it, I think, sometimes like this, because that's, as long as you've done that, you've done everything good, right? Or you may even see it like this. So they'll actually multiply the 4 back in, because we just don't like to see all that complicated stuff inside those brackets here. So how about this minus What do you guys say, pi over 2? So you'll see it that way. And usually we write it that way because it's a simpler form. Dun, 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 dun. All right, what this one is of the challenge problems, this one is the one that's, remember the temperatures, the high temperatures at slow from the beginning of the year till now, or last year, I had to get more. So that's the challenge problem here. So once you can get that, you're gonna try to figure out how to get that in there. We're good? Okay, we're good there? Because high temperature tends to do that, right? They go to a high, then to a low, except they don't go between -3 and 3, correct? They kind of go a little more than that. So how about this? All yours, sine or cosine, whichever one you want. I'm going to go with, I think I wanted this one, yeah. Ten. 110. Let's see, ready for this now? Oh yeah, we can. Yeah, that'll be fun. 20. I'm just making stuff on the spot. It's so fun. And so we have 1, 2. All right, all yours. There's real life situations now. So going from 10 to 1010, oh, sorry, not 1010, 110. And it's, I don't know, if it's a Ferris wheel ride, the person just got on, right? Went up and down and up and down, and it took 20 minutes to go on it, maybe, something like that. It's all yours. Can you think of the equation? Give you guys a minute here. Try it yourself. Try it yourself, see how far you guys can get. All right, I'm going to pause the recording here just so I can. All right, back at it here. So you guys talked to me. How'd you guys get the middle? Guess we need to get the middle first. I know, it's a Monday. And it's before 8 o'clock as well. That's really tough. How do you get the middle of something or the midpoint of something? Go ahead, Adrian, try. Divided in half. If it was going from 0 to that something, yes, divided by half. But it's going from 10 to 110.
90 divided by
Ah, cool. I think we're getting somewhere. May I say subtract the 2, divide and take half of that? I'm not sure if that's right. What do you guys say?
Wait, subtract what to? 110 and 10?
Yeah, we're trying. I don't know. Maybe that's right.
Wait,
I'm not
it's
sure.
110?
It's
Yeah.
110.
Oh,
So it's, yeah, just 100 divided by 2.
that makes so much.
100 divided by 2? That would be 50. So talk to me. Is 50 the middle between 110 and 10?
No.
Yeah?
Wait, yeah.
Yeah, it is. If we're starting at 10.
Yes.
Yeah. So you're thinking like 50. What's the difference between 50 and 10? There's a difference of, right? 50 going down to 10 would be a difference of 40. And then 50 going to 110.
No, 60.
Oh, bummer. That's not the middle. And then scaring us.
Is it 55?
Could be 55. What do you guys say if it's 55? Now we're guessing.
But 60 is too big.
60 is too big, yeah.
Yeah, because
50.
What's 60 plus 50?
Units from 60 to 110.
60 plus 50 is 110.
oh yeah, that is true.
And plus 50 is also 60.
But then how will you find the amount of values between 110 and 10 unless you subtracted it?
Hmm.
Oh, wait, is the, no, because that's not right either.
Okay, now it's past 8 o'clock, so now it has to be good.
Wait, yeah, it is 60.
Oh, yeah, 6,
Yeah.
I already,
I think
yeah,
it is 60.
okay.
Yeah,
What did we
60 on the
just say?
graph is the midpoint, but 50 added, because it's 50 added to 10.
50 added, 50 to 10 is 60. Yeah, pick it 60. 60. You go down by 50 to get to 10,
That was
and you go up by 50 to
way
get
too
to
complicated.
I know. So easier way. Anybody got an easier way to do this?
Well, yeah, if you take the difference between 10 and 110 is 100, and so half of that is 50 plus 10
Yeah.
is
How interesting.
just to,
I wonder if that works all the time. Hold on.
it does. That's the whole point.
300
All the time.
and 150. Okay, the middle of that will be something, right? So what you do, you subtract those two,
So 150.
that'd be one, then divided that by 2, that'd be 75.
Add it should be 225. Which makes sense because 75 on that big side.
No.
Wow, that's interesting. I was thinking just add 110 plus 10 makes 120. Divide by 2 would be done.
Oh, well, that's fine.
It's just only the midpoint from what we learned in algebra. But I like this one. I'm just thinking what
Algebra.
max
Algebra.
minus min, right? Plus min, and that divided by 2. So I wonder what's happening here. So that's 2 mins, right? Added together. That is interesting, Georgia, because what happens is if you do it Georgia's way, so max minus min, right? Then divide by 2. Then you add another min on top of that. And here, this is, sorry, I'm getting common. So maximum minus minimum, right? That's what we did. That's what Georgia did. Divide by 2. And then what she did, she added the minimum back in, right? So if you put this together and you say to yourself, you know what? I want to simplify this so it's all underneath the same exact denominator, right? What happens? You get this max minus min plus 2 mins, and that makes maximum plus a minimum divided by 2. That's cool. It's the same formula, just the more complicated one or the less complicated one. That's cool. All right, I think we're good now. That's beating a dead horse. Here we go, 60. 60 is the midpoint. I think we have everything else we need here. So this is a cosine curve, so I'm looking at this one. So an A cosine B x minus h plus k. Okay, so a few things here. The amplitude. Let's go with the more complicated formula for amplitude. Amplitude would be 110 minus 10. That would be what? 100, right? And then divide that by 2. So if we need a more complicated formula for amplitude, we go max minus min, divide by 2. So that's 110 minus 10 divided by 2 makes 100 divided by 2, or 50.
Wait, why do you have to divide it by 2?
Because we're going this direction, and then we're also going this direction. Right, it's the difference.
Yeah, amplitude is like half the graph.
It's half the duration of the graph, right?
Oh, I see.
Okay, I think we're good there. Now the next one is, I threw in a little bit of a trick here. So what's the cycle here? What's the period? It's only 10. It takes one cycle to get to here. So that means at this point, the period is 10 is equal to 2 pi divided by b. Multiply both sides by b. gets you 10b is equal to 2 pi, voila. So b is equal to 2 pi divided by 10, or pi over 5. Are we good? Hopefully everybody got pi over 5. Matthias, did you get pi over 5?
I did not get five.
Okay.
We're doing public humiliation now, is that how it works?
Just wanted to engage with Matthias, make sure he's good. Are you good?
I'm not incredible.
As the kind of confidence we like to hear.
Okay, are we good with amplitude? Everybody okay with amplitude, first of all? Are we good there? So for this one, for the period, for the b value, trying to find the b value, it's always going to be how long it takes you to do one complete cycle. Took us to be 10, and then it's a little bit of algebra after that. Are we good there? Okay, you guys ask me, okay? That's what we're here for. 50 or negative 50, right? And there would be a cosine, and then it's going to be 5 pi over 5 times x. Do we have a phase shift? Yeah. Do we have a vertical shift? How much is the vertical shift? Is 60, absolutely. That little vertical shift is 60.
So it's the mid.
Mm-hmm. So that's the k value. That's there. Okay.
Wait, the k value is the vertical shift, is that what you said?
Uh-huh. K value is your vertical shift. H value technically are horizontal shift, or if we call it a phase shift. I wonder, and I'm kind of just thinking through this little 4.5 section. I don't see any tangent. It's just sine and cosine. I don't see any tangent, cosine, or sorry, I don't see any cotangent or anything. Apparently. Okay. Talk to me. Are we good there? All right. Let's throw in one more. Exercise 5. And it's going to look something like this. And negative pi over 6. And it's going to go up to pi over 2. And it hits 2 in here. Goes up to 4. And I think we're good there. So go like this. Not drawn to scale here. Hold on. Boom. Let me move this back a little bit here. That's what I want. Okay, all yours there. Let's see. I want a, let's do both here. I would like a cosine and a sine curve.
Wait, is that dot at 4?
Yeah, that guy goes up to 4. So it goes from 0 to 4. It crosses right here. All right, grant a tricky one, all yours.
Solely yours, actually. None of the rest of us are doing that.
Yeah, I'm fine with that.
Okay. I thought you would be.
All right, ooh, as you guys are doing that, real quick here, so notice that I'm favoring the cosine curve a lot of times here. The reason for it is because many times when you're starting something, usually it start at a high position or low position. Like in physics here, if you are going to let's see, undo a spring, right? Let's say something's spring loaded, right? You would pull this down first, right? So it'd be in a low position. Then when you let go, then it's going to bounce like this, right? Normally you don't have something starting in a middle position and all of a sudden like, whoa, I'm going to spring up. No, I'm going to go down, right? Usually it's starting in an extrema view. So potential energy, if you go to physics, potential energy versus kinetic energy, you're going to start in a high position. You're going to start in a hill if the cart's going to roll down. If the cart's on the sidewalk, it's not going to roll anywhere. It's flat. Okay, so my question to you guys, which one did you guys start doing? Cosine or sine? Cosine, yeah, because just the feel of that little piece there here. So y is equal to, if you want to put down the whole entire formula, as we put things together, that's what I have here. Boom. Okay. Amplitude, I guess maybe that would be easiest. Amplitude is just going to be, let's see, the bottom value is 0, the top value is 4, right? So add those, it's 2. Add those up, divide by 2, or you could do George's math. I'm going to go with 2. Inverted, yes, inverted, huh? So it's a -2. You guys, real quick here, also ask me questions as we go, okay? Because you should come home and like, I know what this section's about. I don't want you throwing the textbook across the living room.
Understanding this? Hold on.
Hold on.
Whoa,
I've
holy
been doing this
concept.
wrong.
And then also this funny thing called maybe like looking at the section ahead before coming to class. It's the strangest thing. Do that? That's crazy. All right, cosine. Yeah.
I remember how we learned how to do the textbook method where you set like, you go from, you take what's inside the cosine kind of quotation marks, and then you plug it into the center. And it's like you set up one rotation from 0 to 2 pi, and you like solve it through. So I tried doing that backwards.
Doesn't work as well backwards, huh?
No.
No.
'Cause, I mean, it spit numbers out at me, but I don't think they're correct.
I think that's what we like this formula instead,
Okay.
because we're gonna get it each individually.
So when you're talking,
No,
it
good
sounds like
job.
You have made some breakthrough, like.
I know,
this one
I
works also,
did.
and you're just like, I have no idea.
I don't know.
Okay, we got to get our period here. So I guess we got to figure out this right here. What's how long is it from here to here? That's what we need. So whenever you say, you know, I went from mile markers, I'm hiking, whatever, right? I went from 25 and I went up to 55. How do we figure out that?
They subtract them.
Yeah,
This one we have
we subtract them, huh? So if you say, how did I go from 25 to 55? I went 30, right? So let's move it around. So how about if I go all the way here from negative 25 to 55? What would I do here?
You're subtracting, but you end up adding.
Just add their
add
absolute
that. You have
Yeah.
to make 25 positive.
I mean, that makes more sense to me.
I mean, you
If
can
you-
just do 55 minus negative 25, but it ends up being 55 plus 25.
Yeah.
So on the first one, it was 55 minus 25, right? That gave us the 30. Whoa, hello. Okay, this would be 55 minus a negative 25, right? And that would give us 70, 80? Is that 80? I think that'll give us 80, right? And then we got some innovative math people doing stuff here. Grant says just add their absolute values
All right, that just makes more sense to me.
as long as it's a negative and a positive, right?
Yeah.
Perfect. let's see, and I'm kind of thinking through here. If they were both negative, then it would not work, right? Because they're both on the same side. Okay, so let's go with it. I'm gonna go with the first one. Okay, I may even go with grants as well. We'll see. Okay, plus plus signs over here. Ding, ding, ding. Common denominator would be 6. So how about 3 over 6 over here now? How about a 4 over 6? And how about a 2 pi over 3? Are we good there?
Okay, so no joke, that is what I got when I did the equation.
Oh, awesome. That's cool, Amaya.
Is it?
Let's see. Let me right at the end of class. Let me take a picture of it. I just want to see what
Okay.
how that worked.
Yeah, like, when did I go farther from that?
Oh,
I know, yeah.
I'm really not happy. That's okay.
Okay, let's bring this. Oh, we got to get the b value because that guy is not the b value yet, right? This is just that is equal to 2 pi over b. Oh, this is easy. Look at that. B value is just.
That's so cool.
It's just 3 right away, is that right? Okay, the rest should be easy. The h and k are just from the graph itself. So you're thinking to yourself here, hold on. It's a cosine curve. I went back in time, right? I went back to pi over 6. That is a pi over 6 to the left, correct? So then we just plug in this little value here. Everybody okay with a plus pi over 6? And then did we move up? Yeah, we did. We moved up by a +2, correcto? Oh, where did that come from? That's the middle of this graph right here. If you want a formula for k, right, you could just do k is equal to 4 minus 0 divided by 2, right, if you want to do the formula way. Okay. Real quick. Can anybody give the sine value, sine equation? Because we pretty much, we covered the a and the b. Talk to me. Or is it still too much of a Monday? Let's see, as it starts at negative pi over 6, right? It's going to go up and it hits 2, which is our middle of our graph, right? It hits 2 right here. Doesn't that look like just a continuation of a sine curve? If we wanted to be, I think so. It hits our middle point. So at this point, it's a right side up sine curve. So how about a 2 here? Sine curve. And the b value is 3. Do we have any of a phase shift here? Did we move this sine function right or left or anything? No, perfectly. It's right here. It started in the middle and it kept on going. So that's just gonna be x. The h is 0, and then we moved up by 2. There it is. There's my cosine curve. There's my sine curve, and done. Okay, are we good? I think that's it, guys. We'll be done for today. Okay, guys, ask me the questions if you need it. Otherwise, I'm going to stop here and we'll finish up class and